Hello and welcome. My name's Geraint Jewell from the University of Sheffield, and I'm Director of the Future Electrical Machines Manufacturing Hub. Just by way of a little bit of background to this event, we were scheduled to hold a conventional conference at Austin Court in Birmingham back in June, and we had to postpone that. We tried again for a date in November, but again, because of the current circumstances, we had to postpone that again. So we've decided to put together a series of presentations entirely internally from within the hub on this occasion to give you something of a feel for the activity in the year or 18 months. I don't think we can do full justice as a normal conference would with plenary sessions and exhibits and the like, but hopefully you still find what we've put together useful by way of either an introduction to the hub or a follow-on if you've already become familiar with the activities of the hub from earlier presentations. If you've been following the hub at all and you're fully up to date, if you like, on the structure and the background and the history and the broad work package, you may want to go straight to the technical presentations. If you're new to the hub and you want to understand a little bit of the context, then you might find the remainder of this presentation informative in terms of where the hub's come from and its broad structure and remit. The hub is one of 10 EPSRC manufacturing programme large-scale investments in hubs. The other 9 hubs span a range of topics that are some listed there, drawn from right across the spectrum, from the kind of micro scale to large steel production and kind of all points in between. So a very broad range of disciplines. These were awarded in open competition. We were one of 3 hubs funded in the very last round of the hub programme, and so we started in April 2019. It's a 7-year programme of research with a nominal total funding of £28 million. That's made up of £10.45 million from EPSRC. That's focused on low TRL and public domain dissemination of the outcomes. There's a further 13 million of contribution from industry for projects that are aligned with the hub, that kind of in some cases dovetail quite closely with hub activities, and that's a mixture of cash and in-kind contribution, and is very much an integral part of the hub output and impact. That includes around 20 scholarships for PhD students, and that number continues to grow, and I think in steady state we will probably have a cohort of about 15 or 20 students running through the lifetime of the hub. We also have contribution from the institutions by way of equipment match, by way of some investments in specific posts and teams to support the programme, and from the award of PhD scholarships. So a large contribution as well from the institutions that make up the consortium. The academic partners are drawn from 6 research groupings across 3 institutions. So there's the Electrical Machines and Drives group at the University of Sheffield. There's the Digital Manufacturing group from the Department of Automatic Control and Systems Engineering in Sheffield, and also the AMRC from Sheffield. And from Strathclyde we have input from the Electrical Engineering Department and from AFRC. And from Newcastle it's the Electrical Power Group. So a good mix of large groups, successful groups whose background is in electrical machines, and a variety of people whose background is manufacturing research, including obviously with AFRC and AMRC a significant emphasis on translational research and impact working with industry. Electrical machines is a very big topic, so we've chosen a subsection of that as the focus for the hub, which is on the manufacture of high value, high integrity, low to medium volume electrical machines, and you can see the kind of sectors that have demands in that kind of low volume market. A couple of things about machines of that type: they often have a very high premium on power density in many of the applications, not all but many of the applications. There is a significant value to taking kilograms out of those machines, and so they tend to use very high-end exotic materials, tend to be able to explore advanced manufacturing processes perhaps more than in a more cost-sensitive high volume markets. And there's also the requirement for very high levels of process certification, reliability, integrity, process control and the like. And so we are bringing those two particular technical aspects very much to the fore of the research programme. Having said we have a focus in the hub, we fully expect a lot of spillover of some of the technology, some of the ideas, some of the research methods we develop to more mass market, high volume manufacture. It's not the focus of the hub, but it would be naive to pretend that some of what we didn't have applicability in other parts of the electrical machines manufacturing picture. That hub focus is very much reflected in our starting group of partners. We very much looked at the focus of the hub. We very much looked at our existing partnerships in some areas of real UK strength when we put together our industrial partner consortiums. This slide shows our industry partners, many of whom have been with us since the original bid stage a couple of years ago. They're drawn from many sectors, as you can see, aerospace being particularly prominent, but also offshore renewables, premium consumer products, automotive, material supply, and we also have input from the ATI and the Catapult in terms of giving us wider representation of the industries and wider UK manufacturing. The hub is structured with an executive team, which is essentially a representative of each of the 6 groupings that are involved, along with Laura, the hub manager. We have other academic investigators. We have a team of 16 postdocs, which comes out to about 10 FTE equivalent at any given time. And we have an industry advisory board with 17 members on it currently. That's every member of every industry partner is represented on the Industrial Advisory Board, along with EPSRC. We also have a Scientific Advisory Board, which has 6 members, 3 electrical machines background, 3 manufacturing background, 3 UK and 3 overseas. So a very nice blend of different skills, different expertise, and very much a valued part of the hub. Our 2 advisory boards give us regular and frequent updates. They help us out on particular activities such as reviewing proposals, and are generally very much part of the hub team. Many of them attend monthly technical meetings on different work packages, and we consult with them frequently around changes in strategy, around upcoming plans and the like. We also have a cohort of about 9 PhD students at the moment. That's growing all the time, spread across the 3 institutions, and the earliest ones of those are about a year into their studies now. So we're very much a big and growing team with a nice blend of manufacturing and electrical machines expertise. The work programme of the hub is structured into this quite complicated looking diagram. Essentially, the way EPSRC asked us to structure the main core work programme was around the idea of grand challenge themes. These are pre-competitive research focused on TRL level 1 to 3, and they're split into 2 grand challenges, as we've called them. Manufacturing-led innovation in electrical machines. So this is about taking the very latest and the very best manufacturing methods and seeing what we can do with them in electrical machines in terms of innovation, improving performance. So it's not an electrical machine led activity looking for how would I go and make this. It's rather the opposite. What can we do in manufacturing, and how can we harness that in electrical machines? Drawing in many cases on technologies and ideas and materials principles from other sectors. This is split into 3 work packages, each of which has its own technical presentation in this conference. We've got realising novel machine designs from innovative manufacture, so that's largely led by Newcastle, looking at things like modularisation, integration of heat pipes, and some of the things around manufacturing to enhance performance. So particular focus on heat management at the moment and on modularisation of manufacture. We have a work package on manufacturing of features for in-service performance monitoring. This grew out of a suggestion from one of our industry partners during the formulation of the proposal that very little thought was given at the manufacturing and the design stage to the subsequent use of signatures from that machine for in-service monitoring. So continuous condition monitoring, health monitoring. And so this is an activity looking at the integration of features, sensors, specific devices within the structure of the machine, how you put them in during the manufacturing process to then interrogate them in service. So there's a lot of work going on in this activity at the moment around fibre Bragg gratings, married up with some fundamental work on what happens during temperature cycling of insulation and encapsulants. So that's again a detailed technical presentation on that as part of the conference. There's a third work package in this grand challenge around multifunctional and lightweight components. So a recognition, and there are several presentations elsewhere on the Hub website that you can have a look at, that tell the story around the proportion of machines weight that comes from the structural components, the non-active components, and how there is as much to go at there in terms of power density as there is in the active parts. So there's a program looking at various aspects of design, of manufacture, of how we can make complex forgings, how we can make shafts that perform multiple functions, and so on. And again, I'd urge you to have a look in detail at the detailed work package presentation on that one. We have a second work package on process innovation, monitoring and simulation, and this is looking at the various processes in the manufacture of electrical machines. How can we harness those to improve performance? How can we improve the processes, in particular to give us more repeatability, greater precision, more in-process certification and monitoring? So one of the aspects in GC 2.1, which is from nominal core properties to in-service performance, is tackling this well-known phenomena that there is a tendency for soft magnetic material properties, so that's iron, cobalt iron, silicon iron and the like, to degrade from the catalogue properties to the properties you actually get in service. And we're looking systematically at the various manufacturing process, how they impact on the material properties. So things like pre-compression of a stator core by heat shrinking a casing onto it, or the edge damage caused by laser cutting or by blanking. There's quite a bit of information on those kind of topics for silicon iron. The particular thing we're tackling early on in this is to look at cobalt iron, which is a very high value, very stress sensitive material that's used in very high performance electrical machines, where there's not much anything like as much data on material effects of manufacturing. We're also looking at manufacturing high performance coils with ultimate control. So within this work package is a lot of work on robotic winding, on novel winding types, things like hollow conductors is featuring quite strongly in the work in the first year, and how we would manufacture a very intricate coil with an integral cooling channel. So that's an activity that's very much focused on the coil winding for stators. There's an accompanying work package looking at manufacturing technologies for flexibility and customization. So this is very much tackling the automation of very small batches, even as small as a one-off batch. How do we bring automation into that and the precision and control that gives us while manufacturing small batches? So this is looking at things like remote laser cutting, various robotic manipulation, assembly. What are the opportunities to automate for flexible manufacture? We then have a work package looking at in-process tracking and traceability for zero defect manufacture. Particular emphasis at this work package at this point is looking at monitoring of manual processes. So even in highly automated electrical machine manufacture, there are often steps that involve some level of human intervention. Obviously in small batch manufacture that human intervention goes up. And we're looking at technologies borrowing from other manufacturing sectors around vision systems, smart tools, various aspects that give us in-process monitoring of manual processes to allow us to digitally certify various things that are done during the manufacture of an electrical machine. The other thing, the final work package here is a relatively new addition to the plan, and this is sustainable manufacturing of electrical machine components for the circular economy. This is something we've developed during the first year of the program, this additional work package with input from our industry advisory board and our scientific advisory board, very much led by the colleagues at Strathclyde, looking at what are the technologies, what are the research issues around a full circular economy electrical machine. So this is around repair, refurbishment, recycling, design for disassembly, design for recycling and the like. So a big and growing activity in that area. Around the core programme of the hub, we also have a lot of other projects. So on the left hand side we have some of the lower TRL fundamental research. A lot of that's driven through hub PhD studentships. Some of those are sponsored by industry, some of them are sponsored by the host institutions, and so there's a growing activity on PhD studentships. We have projects, other projects funded by EPSRC in this domain. For example, there are 2 prosperity partnerships that have co-investigators on the hub, and other EPSRC responsive mode projects that are very much aligned with the hub activities. They are separate, but they dovetail in, and they're able to benefit from that kind of collaboration and connection with the hub activity. At the bottom we have an element of the budget which is set aside to engage researchers from other universities outside the existing consortium with proof of concept studies, short research projects, secondments and the like. And so we've just closed our first competition, and so we're soliciting investigator-led ideas for things that complement the hub activity from other partners, and that certainly generated a lot of interest in our first competition that we ran this year. Alongside that we have a activity looking at higher TRL level research. So this is very often collaborative research and development with industry. We have industry funded PhD studentships. We have some direct industry funded projects looking at particular aspects of manufacturing or machine design for manufacturing. We have some catapult projects that are working on electrification that dovetail quite nicely and are able to kind of mutually benefit from hub activities. And we have a whole host of and a growing portfolio of projects funded by ATI, APC, ISCF and the like that very much sit around the kind of general hub activity on manufacturing. So that's all from me really by way of an introduction. It's been very much an introduction to the hub rather than necessarily the conference. I hope you get something out of the technical presentations that are following this introduction. If you want to pick up anything, there are many ways to contact the hub. We have an annual report that can give you a bit more detail, and I hope to see some of you next June, where hopefully we can meet in a more normal environment for a conference with plenary speakers, exhibits and the like. So thank you for taking the time to listen, and I hope you get something out of the technical presentations that follow.